we're going to review our unit on circles and their different theorems. This first one is using theorems about the central angles, and it's not asking for anything specific, so I'm just going to find everything that's missing. So the first thing I notice is that we have a semicircle, which means I can find BC, which would be 180 minus 35, which is 45. Then that's making vertical angles across for EF, which would be 45. And then I can add and subtract from 180, so 45 plus 81 is 126. And we subtract that from 180 and we get 54. And what we want to remember with central angles is that the angle is equal to the intercepted arc. So for instance, if that central angle is 81, then the intercepted arc is also 81. So we just want to remember that property. We don't have to multiply by 2 or anything. Okay, looking at the next one, my goal is to find WV, but sometimes it helps if I just find everything I can find out. So I noticed that they have two congruent angles marked, which means if the bottom one is 5x plus 10, the top one is also 5x plus 10. And then we have vertical angles here. So this is all 12x minus 2. And we can set these equal. So 12x minus 2 equals, I'm going to go ahead and add 5x and 5x is 10x. 10 plus 10 is 20. And we solve, so 2x equals 22 and x equals 11. But it didn't ask me for what x is, it asked me for WV. So there might be a shorter way to do it, but the way I see it is let's plug in 11 for x. So that would give me 5 times 11 is 55, plus 10 is 65. So I know these two angles are actually 65 degrees. And I can add and subtract from 180 because once again we have a semicircle. So that is going to leave me with WV being 50 degrees since our central angle is equal to the intercepted arc. The next one we have chords, and I know that these two chords are congruent because they are intercepting the same or congruent central angles. So y plus 4 equals 2y minus 3. So y equals 7, and they didn't give me any other instructions, so we are going to move on with our life. Alright, next one. I tried to give kind of the most complicated example for this chord one, but there are a lot more straightforward ones. So the trick here is I'm trying to find x, which is on my radius, and I see that my radius is 18.9, but I don't know this kind of little squiggle right there that I'm drawing. I don't know what that piece is, so I need to find that first before I can solve for x. But I'll find that piece and then subtract from 18.9, and that will give me x. So the key to this one is to think about swinging your radius over to make a right triangle. So this makes a right triangle with a hypotenuse of 18.9. And one of my sides is 15.7. So I can use the Pythagorean Theorem, so say 15.7 squared plus b squared equals 18.9 squared. And we want to be careful that you're putting the 18.9 in the c because it's opposite your hypotenuse. So we're going to do this. 18.9 squared is 487.21. I don't have my fancy calculator, so I'm doing this all on my phone calculator, which is more time consuming. Solve for b squared, so 487.21 minus 246.49. So 240.72. And that means the square root of that is 15 0.5, but I don't want to start there because that is giving me, this piece is 15.5, and that's not what it asks for. So I need to do 18.9, my whole radius, minus the piece I just found, 15.5, and that's going to give me 3.4 as my final answer. So next we have the type of angle that's called an inscribed angle. An inscribed angle has a vertex on the circle. And the relationship for an inscribed angle is that 2 times your angle equals the intercepted arc. So 2 times my angle is 31x plus 3 equals 192. So distribute 62x plus 6 equals 192. So we'll do 192 minus 6 and divide by 62, and we get that x equals 3. Since they didn't ask me for something specific, we're just going to move on with our life. The next one is giving me inscribed angles, but they are also making a quadrilateral. So what we want to know is that in a inscribed quadrilateral, opposite angles are supplementary. So my blue arc plus my red arc is 180. So we're going to substitute in our values and solve. 21x minus 2 plus 38x plus 5 equals 180. Something that is tempting is for you to set those equal, but that's not necessarily true. So when I combine like terms, I get 59x plus 3 equals 180. Subtract 3 from 180. And divide by 59. And I get, once again, x is 3. In the next problem, this is when we ask, is it tangent or not? If a segment is tangent to a circle, then that means it's going to be perpendicular to the radius or diameter. So in this one, I'm basically seeing if this makes a right triangle, so I'm going to check with Pythagorean Theorem. So I have that my whole possible hypotenuse is 20. I have one of the sides is 16, but what is this other side? Well, we need to notice that this is the radius of a circle, and what is the radius of this circle? 12. So we're going to check and see if 12 squared plus 16 squared equals 20 squared. And this one is going to work out. It's actually a multiple of a 3, 4, 5 right triangle by multiplying 3, 4, and 5 by 4. And we get 400 equals 400, which means that, yes, they are tangent. In the next one, we're given that something is tangent, and we want to solve for the missing side. One thing that's tempting, and I saw people do on the test, was they just said right here, 6 squared plus 6.4 squared equals c squared. But that 6 is only going for the radius, which means I need to go another 6. So what am I going to substitute into my equation? I'm going to use 12. So 12 squared plus 6.4 squared equals c squared. And when I solve for c, I get 13.6. Continuing with some other tangent problems, in this question we want to find the perimeter. So to find the perimeter, I notice that I'm going to need this side and this side that I don't have yet. In order to do this, you kind of need to start where you have some information and go from there. So for instance, if I know that this side is 13, then this side is 13. I think of it like an ice cream cone. There's the cone, and then my circle is the ice cream. You get it? Okay, and then if the whole side is 25, then that means this piece is 12, 12, and so I can do 21.8 minus 12, which is 9.8. So this is 9.8. And then I have the other piece is 4.6. Okay, so perimeter would be 25 plus 21.8 plus 9.8 plus 4.6 plus another 4.6 plus 13. So 78.8. If two tangent segments intersect at the same point outside the circle, then that means that their segments are congruent. So 2x minus 5 equals x plus 3. So that means that x equals 8. Now we're going to look at some other types of relationships. So these ones are where we're either intersecting outside or inside the circle. So this one intersects outside the circle. So 2 times the angle in question equals the far arc minus the near arc, and you need to remember to put parentheses. So 2 times my angle here is 50 equals 12x plus 8 minus, in parentheses, 4x plus 4. So when I distribute, I get a negative there, which is super important. Minus 4x minus 4. So 100 equals 8x plus 4. So 96 divided by 8, x equals 12. The next one intersects inside the circle, so 2 times your angle equals the sum of your two arcs. So 2 times an angle of 124 equals 197 plus 9x minus 3. So 248 equals 194 plus 9x. And x equals 6. So I noticed that this next one is intersecting outside the circle, so 2 times the angle equals far minus near. But as I try to start substituting, so 2 times my angle, 5x plus 10, no big deal. I don't know what my far angle is, but I know my near one is 110, so at least start there. Well, now we want to kind of divorce ourselves from the question at hand and think, if I know that that arc is 110 degrees, could I find out what my far arc is? Yes, we could do 360 minus 110 and get 250. And now I can use that in my equation. Bear with me with my handwriting. My hand is cramping, so this is quite fun. Said no one ever, but that's okay. All right, 140. So then x is going to be 12. The next one, we have the vertex of my angle is on the circle. Technically, this is a tangent angle, but we can treat it like an inscribed angle because the vertex is on the center. So 2 times my angle equals my intercepted arc. So 2 times 7x minus 10 equals 120. So 14x minus 20 equals 120. So x equals 10. All right, the next section that we did was on sector area and arc length. So this first one I want us to find sector area, and unless it tells you to, we're always going to leave things in terms of pi. So for sector area, that's where we have our degree, so that's 140, out of 360, that's the whole circle. And if we want area, then we're multiplying by pi r squared, so 18 squared. So basically I'm just going to ignore pi while I simplify things. And I get 126 pi. Now we have your favorite questions. And if it was arc length, I would just change that part to 2 pi r. Okay. Given a circumference of 50 pi feet, find the area of a sector whose central angle measurement is 40 degrees. So I want eventually to find sector area. So sector area is degree over 360 times pi r squared. So they gave me the 40, but I don't know my r. So what I need is, obviously, r. So I go back to what else they gave me, circumference of 50 pi. So circumference is 2 pi r. So if they give me that, 50 pi is my circumference. Well, my pi's will cancel, and I get that my radius is 25. So my sector area is going to be 69.4 repeating pi. So I'm just going to say 0.4. The next one says find the diameter of a circle that has a 100 degree central angle with an intercepted arc that is 3 pi units long. Okay, so none of my formulas have had diameter in it, so that probably means I'm going to find my radius and then multiply by 2. So 100 degree central angle over 360. It's talking about length, so 2 pi r, but it's not giving me r, it's giving me what that length is equal to, which is 3 pi. So I'm going to be solving for r and then multiplying by 2 at the end. Okay, so we're going to get 3 times 360 and divide that by 200, and I get that r equals 5.4. So that means my diameter is 10.8.